Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Today we are going to continue. I'm going to continue our discussion or lecture of 6.0 polynomials, lecture 4 of 4, 6.3 partial fractions. Okay, so please get ready, recall your lecture notes with in your hand right now, and without wasting so much time, let's continue. So for today, we're going to continue the lesson that we have discussed on 6.3, partial fraction. Okay, in this case, we are going to face a question where we need to change the rational polynomials to the proper fraction when the degree of the numerator is equal or same or greater than or more than of the denominator. Okay, and determine the partial fraction. So it means that the key for this part, okay, the key for this part here now is, for example here, okay, change the rational polynomials, okay, to proper fraction when the degree of the numerator is the same or greater than, equal or more than we call the degree of the x from denominator. Okay, so in this case, for example, when we have x squared minus 2x divided by x squared plus 2x minus 1, where the degree of x from numerator is equal with the degree of x from denominator. Okay, or x cubed minus 1 divided by x squared minus 5x plus 1, where the degree of x from numerator is greater than the x from denominator. Okay, and then we're going to determine the partial fraction. So long division is needed. So long division is needed to reduce the improper fraction to a mixed form consisting the sum of polynomial and a proper fraction. For example, here, okay, so we have, okay, x cubed. X multiplied with x is going to give you x squared plus x, where x degree here is 2. So 3 is greater than 2. The degree of x from numerator is greater than degree of x from denominator. This is what we call an improper fraction. Okay, and we are going to come up with, let's say, the result of the long division, x cubed plus 2x minus 6 divided by x multiplied with x plus 1. Division of this going to give you x minus 1. And look at this one here now. This one, x multiplied with x, we're going to give you x squared plus x. And the degree of x of numerator here equal to 1. And here is 2. So the degree of x from numerator is less than the x of the denominator from denominator. Then now, this is a proper fraction. Okay, from improper to proper fraction, we need to use the long division. Okay, and that's a polynomial of x minus 1. Okay, now using long division, show that this one here now express of x squared minus 2x, this one here, as a partial fraction. I rewrite the question here, x squared minus 2x, x squared minus 2x divided by x squared plus 5x plus 6. Okay, so in this case, we're going to use a long division, x squared minus 2x. Okay, assume that there's a 0 here, plus 0, and divide by x squared plus 5x plus 6. Okay, so x squared divided by x squared equal to 1. Again, 1 multiplied with x squared, 1 multiplied with 5x plus 5x, and 1 times 6 equal to 6. Okay, so now x squared minus x squared. Clear. Negative 2x minus 5x, negative 7x. 0 minus 6 equal to negative 6. Okay, so now, in this case, for x squared minus 2x divided by x squared plus 5x plus 6 equal to the quotient here, which is 1 plus, okay, negative 7x minus 6 divided by x squared plus 5x plus 6. Okay, it is now 1, negative, negative, make it in here, negative minus 7x plus 6 divided by x squared plus 5x plus 6. Okay, now this is the part that we're going to continue our discussion here. Okay, in the process of recall to give process of partial fraction. Okay, so then 7x plus 6 divided by x squared plus 5x plus 6, or is 7x plus 6 divided by x squared plus 5x plus 6. Can we factorize this? Yes, it is now become x minus 2, x plus 2, and x plus 3. Again, x multiplied with x, x squared. X times 3, 3x, 2x, 3 plus 2 equal to 5x, 2 times 3 equal to 6. So now, this is the one that we're going to come up with. A divided by x plus 2 plus with b divided by x plus 3. Okay, so now we are going to equalize these two fractions with that fraction on the left side here. And we're going to multiply with x plus 3 divided by x plus 3 here. And also here, multiply with x plus 2 and x plus 2. Okay, so now, both of, we call the denominator of all this fraction. This one, the denominator is x plus 2 multiplied with x plus 3. The denominator of this is also x plus 2 multiplied with x plus 3. And the denominator of this fraction also now, here, it is now x plus 3 multiplied with x plus 2. So we already equalized the denominator of these two fractions with the origin question here. So what we next part is we just focusing on the numerator, which is 7x plus 6 equal to, okay, a x plus 3 plus with b x plus 2. So now we are going to find the the value of a and b. Class, so I'm recall using the back factor here. Let x equal to negative 3. Why? When x equal to negative 3, negative 3 plus 3 equal to 0. Yes. Okay, so we're going to substitute x with negative 3 here, here, and here. So 7 times negative 3 plus 6 equal to a, negative 3 plus 3, plus with b, negative 3 plus 2. Okay, 7 times negative 3 equal to 7 times negative 3 equal to negative 21, plus 6 equal to negative 3 plus 3 equal to 0. Negative 3 plus 2 equal to negative 1. So negative b. Negative 21 plus 6 equal to negative 15. Then b equal to 15. Okay. And then let x equal to -2. According to this one here, x -2. -2 plus 2 equal to 0. Okay, so then let x equal to -2. So 7 times -2 plus 6 equal to a. -2 plus 3 plus with b -2 plus 2. Well, this is going to be 0 here. 7 times -2 equal to -14 plus 6 equal to -8. So -2 plus 3 equal to 1. 1 times a equal to a, then a equal to -8. Okay, class. Look at this one here now. 7x plus 6 divided by x squared plus 5x plus 6. This one, we already elaborate in this form. A divided by x plus 2 and b divided by x plus 3. So here now, it become 1 minus, okay, change this in the form of this. We have elaborated this earlier here. 7x plus 6 divided by x squared plus x plus 2 multiplied by x plus 3 equal to a. And the value of a here now is -8. Okay. Okay. Where a equal to -8. -8 divided by x plus 2. -8, a divided by x plus 2, and b equal to 15 divided by x plus 3. Okay, so simplify this. 1 negative times negative equal to positive divided by ax plus 2 and minus 15 divided by x plus 3. Okay, there you go. So x squared minus 2x divided by x squared plus 5x plus 6 equal to 1 plus 8 divided by x plus 2 minus 15 divided by x plus 3. Okay, so class, actually that I just give you a simple example where in which other topic that we're going to meet with this all again. Okay, we are going to meet with partial fraction again in some other topic. For example, x squared minus 2x divided by x squared plus 5x plus 6. We are going to find this all again. Can you guess in which topic that I mean it? Okay, here it is. Okay, so integral of all this function respect to the x equal to the integral of all this respect to the x. But then this one we're going to meet in the topic of integration. So, okay, just for your information. Okay, at this moment, just to inform you that we're going to meet again in some other topic, but don't, okay, ignore it for a while. Okay, now, second, express this as a partial fraction. Okay. 2x to the power of 4 divided by x plus 1 and x squared plus 1. Okay, now, again, we are going to come up with a long division here. 2x to the power of 4 plus 0x cubed plus 0x squared plus 0x plus 0, and divide everything by, okay, let's say we expand this. X plus 1 multiplied with x squared plus 1 equal to x times x cubed plus with x plus x squared plus 1. Or we call arrange this x cubed plus x squared plus x plus 1. Okay, so now this we're going to divide by this one here, x cubed plus x squared plus x plus 1. Okay, so now let's divide this one by one here. 2x power 4 divided by x cubed. I'm going to give you 2x power 4 divided by x cubed, x. Okay, so 2x times x cubed, 2x to the power 4. 2x multiplied with x squared, 2x cubed. 2x times x plus 2x squared. 2x times 1 equal to 2x. Okay, so 2x power 4 divided by this 4 minus 2 4 habis clear. 0 minus 2 negative 2x cubed. 0 minus 2 minus 2x squared. 0 minus 2 minus 2x, and bring down here 0 here, right? Okay, so negative 2x cubed minus negative 2x cubed divided by x cubed minus 2. Okay, so negative 2 times x cubed minus 2x cubed. Negative 2 times x squared minus 2x squared. Negative 2 times x minus 2x, and negative 2 times 1 minus 2. Okay, so this one here clear. Negative times negative positive, so negative 2 plus 2 clear. Negative multiplied with negative equal to positive, so negative 2x plus 2x clear, and 0 negative positive plus 2. Okay, so then here now this is the one. 2x minus 2 plus with 2 divided by x plus 1 and x squared plus 1. Okay, so now this is the one that we gonna perform with partial fraction. So 2 divided by x plus 1 and x squared plus 1 equal to a divided by x plus 1 plus with, okay, now class, so now we are going to come up with a partial fraction here. A divided by x okay, and then this fraction with x squared plus 1. Okay, now the denominator of the first partial fraction here, x plus 1. So above here we come up with an a. But then in this case, we call the denominator is x squared plus 1. So above here we're going to come up with the degree of x which is lesser than 1 than this. So we're going to come up with bx plus c. Okay. So now we're going to equalize the denominator of this fraction and this fraction with this one. So the denominator here now is x plus 1 multiplied with x squared plus 1. So we already have x plus 1 here. So we need x squared plus 1. And also above here x squared plus 1. And then for this fraction, we already have x squared plus 1. X squared plus 1. So what we need here right now is an x plus 1 and x plus 1. Okay, so now we call the denominator of this fraction are equal with this and this one here now. So we may just focusing on the numerator. 2 equal to a x squared plus 1 plus with. Okay, so now we call the numerator which is 2a x squared plus 1 plus with bx plus c and x plus 1. Okay, so we're going to come up with a few values of x. There are two different methods, guys and girls. First is we expand everything here and compare with the one on the left side. For example, if we have ax squared plus a x times x equal to x squared, so we're going to come out with 0x squared plus 0x plus 2. But since that, okay, that's the first method. Expand everything and compare the coefficient of x squared, x, and we call the constant with a 0, 0, and 2. Okay, that's the first method. Second method is, we just simply substitute the value of x. That can simply recall the possibilities of making the whole function, we call the whole term here equal to 0. Okay, so for this one here now, let x equal to -1. Why? -1 plus 1 equal to 0. 0 multiplied with c equal to 0. 0 multiplied with bx equal to 0. So then what's left here now? 2. Okay, for example, 2a -1 square plus 1 plus with b -1 plus c and -1 plus 1. So -1 plus 1 equal to 0. 0 multiplied with c and b -1 here is everything equal to 0. So -1 square equal to -1 square equal to 1. 1 plus 1 equal to 2. So 2 equal to 2a, then a equal to 1. Okay, then again, for second time, let x equal to, okay, let's take a look at this one again. We have x squared plus 1 and x plus 1. Do you find any value of x that can simply make this x squared plus 1 equal to 0? Nope. Okay, so just let it be them. Let's assume, let's just think of any value of x that at least makes the equation simple, with the simple numbers then, yeah. Okay, let x equal to 1. Okay, when x equal to 1, we call the constant of 2 remain here. 2 equal to, okay, we already found that the value of a equal to 1. So 1 and 1 square equal to 1. 1 plus 1 equal to 2. Plus with b multiplied with 1 plus c and 1 plus 1 equal to 2. 2 here. Okay, 2 equal to 2 plus b times 1 equal to b multiplied with 2 equal to 2b. And then c times 2 equal to 2c. Okay, let's think of something else. Let x equal to 0. Why? Because we already have one equation here. 2 bring to the side become -2. -2 plus 2 equal to 0. Then 2b plus 2c equal to 0. And then when x equal to 0, okay, and then here, okay, I'll use this again. 2 equal to a equal to 1. So then 1 and x equal to 0. 0 squared equal to 0 plus 1 equal to 1. Plus with x equal to 0. 0 times b equal to 0 and c. And then x equal to 0. 0 plus 1 equal to 1. So now, guys, girls, this is 1. Bring to the side become negative. So 2 minus 1 equal to 1 and c equal to 1. So when c equal to 1, we can use this here. Okay. So then 2b plus 2 and c equal to 1 equal to 0. Then b equal to 2 bring it to the side become negative minus 2 and b equal to -1. 1. Okay, so we find it here where C equal to 1 and B equal to negative 1. Okay, now so now guys, girls, look at this and this. So now 2x minus 2 plus with 2 divided by x plus 1, x squared plus 1. You are reforming we call the partial fraction here and here. So then a equal to 1. So then 1 over x plus 1 and b equal to negative 1 plus with negative x and c equal to 1. Negative x plus 1 divided by x squared plus 1. X squared plus 1. Okay. Okay, class. So right now, let's see the step that I use here. The first is use the long division to form a we call polynomial here and a proper fraction. Then next is form this into a proper we call in partial fraction, and then find out the values of a, b and c and substitute a, b and c here, and this is the proper fraction of for the question here. Okay, so next question then. Okay, express this in partial fraction. Okay, so now x squared multiplied with x is going to give you x cubed. Okay, we have here 3x cubed. And also x squared multiplied with x cubed. So the degree of x from numerator and denominator are equal now, and this is improper fraction. Okay, so we need to change this in the form of proper fraction first. First thing we're going to do here is to come up with a long division. Long division, okay, from 3x cubed plus 12 divided by x minus 1 and x squared plus 2, x times x squared, x cubed, x times 2 plus 2x minus x squared minus 2. Okay, so this one here now come out with x cubed minus x squared plus 2x minus 2. Okay, so now guys, girls, let's change this in the proper fraction first by using long division. 3x cubed plus 0x squared plus 0x plus 12 divided by x cubed minus x squared plus 2x minus 2. So 3x cubed divided by x cubed equal to 3. 3x cubed, 3 times negative x squared minus 3x squared. 3 times 2x equal to 6x. 3 times negative 2 equal to negative 6. So 3x cubed minus 3x cubed, clear. Negative times negative equal to positive. So 0 plus 3 equal to 3x squared. Negative, okay. 0 minus 6, negative 6x. 12 negative times negative equal to positive. So 12 plus 6 equal to 18. Okay. So this one here now equal to 3 plus 3x squared minus 6x plus 18 and divide by x cubed minus x squared plus 2x minus 2. Okay, so now this is the proper fraction. This is the proper fraction that we are going to express in partial fraction. Okay, so expressed in partial fraction here, 3x squared minus 6x plus 18, and this denominator are actually come from this. So it is now x minus 1 and x squared plus 2. Okay, x squared plus 2 is a quadratic that cannot be factorized anymore. So it's standing on its own here. Then we are going to... Okay, so first is a divided by x minus 1 plus with, okay, x squared plus 2. X squared plus 2, the degree of x of denominator is 2. So above here, we're going to come up with bx plus c, which is the degree of x equal to 1 less than 1 of the x from denominator. Okay. Okay, now we are going to equalize the denominator of these two fractions with this. Okay, so we already have x minus 1, so we need another of x squared plus 2. Divide, okay, x squared plus 2 divided by x squared plus 2, and here we already have x squared plus 2. We need another of x minus 1 divided by x minus 1. Okay, so these two, we call these two denominators of this fraction are now equal with this. So we may just ignore the denominator, and now we can just simply we call focusing on the numerator, which is 3x squared minus 6x plus 18 equal to, okay class, from example 1 and example 2, I use the method of, we call substitute the value of x that we choose based on the value of x from these factors that can possibilities that making the whole everything here equal to 0. But now I'm going to expand this. Okay, a times x squared, ax squared plus with 2a plus with bx times x, bx squared, bx minus 1 minus bx c times x plus cx c times negative 1 minus c. Okay, so now we're going to compare 3x squared minus 6x plus 18 equal to ax squared with bx squared, a plus bx squared. Okay, and the coefficient of x and x, we have negative b and c plus with negative b and c for x. Then next is 2a minus c. Okay, now we are going to compare the coefficient of x squared, a plus b with 3. The coefficient of x, negative b plus c with negative 6. And 2a plus c with 18. Okay, so let's try. Where first here, a plus b equal to, a plus b equal to 3. Equation 1. Negative b plus c equal to, negative b plus c equal to negative 6. Equation 2. And 2a minus c, 2a minus c equal to 18. Equation 3. Okay class, every single equation here, a and b, b and c, a and c, there are none of these with for example, a and b, a and b. Okay, it's quite difficult here, a little bit difficult here, but then let's try. Okay, so let's try from equation 2. From equation 2, then c equal to negative 6. Negative b bring the side become positive. plus b. Let's make this equation 4. Okay. Let's clear this. Okay. It's now okay. Substitute equation 4 into an equation 3. Why? Sub equals c equal to negative 6 plus b. Substitute here and everything will come out with equation 3. Just now, right now we have a and c, and then it become a and b. So we may compare equation 3 with equation 1. That's it. Okay, that's my idea. So let's see here now. Equation 4, substitute into equation 3, 2a minus c, 2a minus c, where c now from equation 2 it is negative 6 plus b. Negative 6 plus b equal to 18. So 2a plus 6 minus b equal to 18. Then 2a minus b equal to 18. 6 positive bring to the side become negative. So 18 minus 6 is 12. Equation 5. Okay, now let's compare equation 5 with equation 1. We already have a, b here, and now we have a and b. So guys, girls, I'm sorry if because I like to show everything in one page and look messy here, but I hope that all of you understood. Okay, so now it's between equation 5 and equation 1. Okay, equation 1 we have b and negative b. Equation 1 plus equation 2. So 2, okay, equation 1 plus equation 2, a plus b equal to 3. And 2a minus b equal to 12. Plus here, according to this. Okay, a plus 2a, 3a, b plus negative b. Positive with negative is negative, so b minus b equal to 0. 3 plus 12 equal to 15. Then a equal to 15 divided by 3 equal to 5. So now when a equal to 5, then we may substitute here 5 plus b. Substitute a equal to 5 into equation 1. A equal to 5 plus b equal to 3. Then b equal to 5 bring to the side become negative. So 3 minus 5 equal to negative 2. And then to find the value of c, let's use equation 4. Okay, so then c equal to negative 6 plus b, which is negative 2. So c equal to negative 8. Okay, so I'm going to list down here the value of a equal to 5, b equal to negative 2, and c equal to negative 8. Okay, so now okay, look at this. From improper fraction, we use the long division to form this polynomial with a proper fraction. And from proper fraction, then we form into a partial fraction. Okay. So now it's time for us to substitute the value of a, b, and c into this partial fraction. Okay, so now 3 plus a, where a equal to 5. A equal to 5, so then it is now 5 divided by x minus 1 plus with, we have b and c, where b equal to -2, c equal to -8, plus with negative, okay, b equal to -2, x minus c equal to 8, divide by, we have x squared plus 2. There you go. Okay, this is it. Okay, so 3 plus 5 divided by x minus 1 plus -2x minus 8 divided by x squared plus 2, or you may simply write down this as a 3 plus 5 divided by x minus 1 minus, okay, negative and negative factorize, take it outside, then it is 2x plus 8 divided by x squared plus 2, either one. Okay, this is correct and this is also correct. So class, these 3 examples, I do hope that recall my explanation, these 3 examples really helped you to understood, and you may test this exercise by yourself. Make sure that you get a p equal to 2, q equal to 1, and this partial fraction as your final answer. So then a partial fraction, if it is improper fraction, then we can simply we can simply form in what we call partial fraction. But if it's not if it is in improper fraction, then we need to use the long division to form the proper fraction. Then we come up with a process of partial fraction. So that's all for today. Thank you very much. Till we meet again. And I do hope that these videos really benefit to all the students. And that's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day. Till we meet again. Bye.